Hello, everyone, and welcome to our discussion today on Forcepoint's point of view on zero trust and all the solutions that we can bring to bear on the challenges. Now, hi, I'm Scott Tesh. I'm with Forcepoint as a Sales Enablement Program Manager, and today I'll be joined by Dr. Nick Lessen, one of our principal sales engineers, who will talk through our perspective on zero trust. And then, of course, we'll hear from Evan Nelson, a sales engineer from Forcepoint, who will talk us through how several of our technologies can be combined to meet the use cases that ATARC has set out. So in terms of the agenda today, we'll start with a brief discussion of some of our backstory and our unique position that allows us to help customers with high consequence missions. We'll then hear from Dr. Lessen about Forcepoint's zero trust point of view, as I mentioned. We'll talk through an overview of our Forcepoint 1 solution, and of course we'll get into the demonstrations and some of the use cases, and we'll end with some Q&A. So let's start with where we came from and how we look at trusted high assurance cybersecurity. So a little history. We were formed in 2016 by Raytheon Cyber Products, joining forces with WebSense in order to bring defense-grade cybersecurity technology to the enterprise security marketplace. Now, at this point, the global governments and critical infrastructure part of our business was born within Forcepoint, focusing on cybersecurity technology, which is associated with cross-domain and insider threat use cases. After the joint venture was created, Forcepoint acquired capabilities in next-generation firewall, cloud access security brokering, user and entity behavioral analytics, and remote browser isolation, and we built out our secure access platform combined with an industry-leading data protection suite. Now, in terms of some of our latest additions to our strong suite of cyber capabilities, last year we acquired DeepSecure, which provides us with zero trust content disarm and reconstruction, or CDR capabilities, and Forcepoint overall acquired BitGlass, a leader in Security Service Edge, or SSE. So today we'll focus quite a bit on some of those secure service edge capabilities with our best-in-class platform that we call Forcepoint 1, which features Cloud Access Security Broker, Secure Web Gateway, Zero Trust Network Access, and Data Loss Prevention, all managed seamlessly from a single console. So a lot of capability to talk about here, but it all contributes to our overall mission, which is providing trusted high-assurance cybersecurity to customers with high-consequence missions. So a little bit about our organization, by the numbers, if you will. We're the largest privately held cybersecurity company out there. We're also the largest supplier of cross-domain and insider threat technologies to governments and critical infrastructure providers worldwide. We support 100% of the U.S. federal government agencies, and we have over 600 employees dedicated to supporting our G2CI customers. Now, with over 3/4 of those folks carrying clearances, we have unparalleled capability to serve all missions. We also continue to innovate. As you can see here, overall, Forcepoint has more than 420 patents and applications, and we're adding new capability every day. Okay, now I'm going to talk a little bit about the Kool-Aid, right? What's our manifesto? So this is what we believe in. It's what drives us, and it's pretty simple. We were born with a passion to help our customers with their high consequence missions, and we're also passionate about being a force for good. We're like no other technology company out there because not only do we innovate as a commercial cybersecurity software provider, we support and understand what it means to support global governments and critical infrastructure customers in those high consequence missions. Now, it takes a whole different level of focus and understanding to be able to do that, but it's also important to call out, we're not necessarily for everyone. If just good enough is good enough, we may not be the right fit, because we take this very seriously and we focus on customers that have these high consequence missions because they need the absolute best in cybersecurity technology and have very many unique requirements that most commercial entities don't have. We're problem solvers. We have the best of the best in our professional services organization that I mentioned. In our product engineering organization, we all swarm problems and solve some of the most unique challenges that our customers face. So we understand the pressure that our customers face with their high consequence missions that they're called to support, and we're proud to make it our own calling and be part of that. Now let's look at how we do that. How do we get to our gold standard? Our gold standard being delivering a trusted high assurance architecture that embodies 6 key design principles in our product portfolio, which I'll go over in a second. But at the end of the day, we're a software company. We build software the government wants, and we build and continue to develop those products based on critical input from our customers. We don't build products without a mission. And in addition to those great products, we have highly specialized professional services departments that help those missions become a reality. Now, although some vendors can bring some of our capabilities to the table, we're unique in terms of not only getting our solutions ready for mission success with customers, but also having it fully accredited and functional in a timely manner for our customers. That's really what's given us this moniker of trusted high assurance. It's how our customers look at us out there in the marketplace. A few of our key design principles that we've developed from that long history are what continue to drive our development and delivery today. So first and foremost is that we're fit for purpose, as I've mentioned. Second, that we can provide deep context, elevating awareness about what's going on with the organization and the mission, and providing an unsurpassed depth of observation. We design with the aim to protect at digital speeds with the lowest latency possible, and of course, near and dear to this presentation, embedded trust is a core design principle, and we believe that governance is foundational. It provides full integrity across the stack, deep into the OS, all the way down into the subcomponent level. Now, we've got a track record that you might be surprised to hear about. We formed Forcepoint with an already 20-year history supporting the highest consequence, highest stress environments. And of course, if these past few years have proven anything out, it's that we need to be flexible and multi-generational, allowing our solutions to work across different types of environments, whether it's a legacy solution stack, it's out in the cloud, it's part of a hybrid solution, or working from the edge. So all of this adds up to why we're different. We're about providing high assurance security for your critical missions delivered at the speed that customers expect from a commercial partner, and we're maniacally focused on your mission. Okay, now cue the typical objection, right? Everybody says that. So our response to that is pretty simple. How many of those everybody's are in these types of environments trusted by these kinds of people? How many of those everybody's are willing to give you references? We live and breathe this for our customers. And with that, I'll hand the floor over to Dr. Nick Lessen, who's going to take this further and talk about our perspective on zero trust principles. So take it away, Nick.
Thank you, Scott, and thank you, Evan. So Forcepoint supports zero trust as is defined in 3 major points of view. And if we can go one slide over. The first one is the Nist 7 tenets of zero trust. And as you can see, they're kind of building out now. The next one we'll talk about is the zero trust maturity model by the Cybersecurity Infrastructure Security Agency, Cisa. And then third, we'll go over to DoD zero trust reference architecture really briefly. So what you see here are the 7 tenets, and just in case some of you may or may not have seen this before, these are the 7 main concepts that you need to adhere to when you're establishing a zero trust framework. And the first one, quite simply on the top left, is making sure that you've got technical enablers where you've got the enterprise capable of collecting as much information about your assets as possible. And you'll see this in systems like CDM, continuous diagnostics and mitigation, because it's essential to know what you have if you're going to be formulating any kind of strategy to protect your assets. You need to know exactly what you have. Secondly, you need to have a capability to monitor and measure the integrity and security posture of all said assets. This means you need to know how those assets are in terms of patches and all kinds of builds and any kind of software that's going to keep track of the health of that system. Third, we're talking about person and non-person entity authentication. This is to ensure that we are not just covering humans, we're covering devices as well. And more specifically, we're looking at the authentication and authorization process. We're wanting it to be dynamic, meaning we're moving away from the static access controls where you're just letting someone or something get authorization and you're just leaving it until some human comes along later and then changes that access. So we're talking about having a dynamic way of changing access. On the top right, you're seeing how we're classifying data sources and computing services as resources. This is to expand our thinking in terms of what we are protecting, because too often we're thinking we're just protecting data. That is not the case. We need to be protecting your resources as it stands, whether it's user accounts, whether it's devices, handhelds, all of those things count as resources and they all should be protected. Next, all communication should be secure regardless of where it is. As you know, we're talking about having end-to-end encryption. We're looking at not just our assets that are simply inside of our organization now. We've got remote workers, we've got the cloud, we've got so many places where those said resources can exist. And anytime we interact with them, there should be secure communications. Next, we talk about those access to those enterprise resources on a per session basis. And this goes back to the other tenet where we were talking about that dynamic authorization. This is saying that no longer should we just authenticate once to a network and then have all the keys that we need to do our job. This suggests that our technical architecture is going to have means to then revisit authentication every time an identity, a non-person or person entity is reaching out to a resource. There needs to be that constant process of checking credentials and posturing. And finally, this is summing it all up in terms of having that dynamic policy. You're supposed to be having these technical systems that can see what the client's identity is, whether it be an application or a service, and looking at both the endpoint and the destination and source. And you're going to include things like behavioral and environmental attributes. This is to say that we are going to include additional context when we make these access decisions. That additional context can include things like location, time of day, and also something like a confidence score. And we're going to show you examples of how many of these tenets are to be implemented using Forcepoint technology. Next slide. Secondly, I did mention that we're going to talk about the Cisa maturity model. This maturity model is an important tool to help organizations understand where they are in their journey and where they need to go. And for those of you that haven't seen it, it uses the construct of pillars organized in this matrix. And each pillar is going to represent those categories of technology that organizations should be adopting and incorporating into their architecture. Starting from left to right, you've got identity, you've got all of your systems that contribute to tracking and managing digital identities across your enterprise. You've got devices, your network, your application and workloads, and data. And when you look at this particular matrix, it doesn't only have suggested technologies that are core for the organization to adopt, but it includes 3 levels of maturity that organizations can use to see where they are, what they need to do. Beginning with traditional to optimal, traditional being the lowest level of maturity and the standard to begin with, you will see in those columns those specific traits that organizations should have with the technology that they implement in the respective pillars. Now you'll also notice that there are arrows going across, and they're also titled visibility and analytics and automation. What that means is that there should be interaction between all of these pillars with visibility and analytics automation capabilities. For those of you that have been looking at zero trust architectures from other industry vendors and other government papers, you may have noticed that there were 7 pillars, whether it's from Forrester or the Department of Defense model. Those other 2 pillars included visibility and analytics as separate tiers, if you will, that included certain capabilities. Those capabilities were responsible for not only assessing what the digital identities across the enterprise are doing and assessing their levels of trustworthiness, but also providing automation to disseminate that information and institute that dynamic reauthorization that we just talked about within the Nist tenets. Cisa has taken this a step further, and they recognize that even though those are essential capabilities that should be recognized, instead of putting them in pillars, they made them foundational, and that relationship is the same. DoD as well as Cisa both recognize that the visibility and analytics pillars and capabilities should be interacting with all of these other pillars. And so that's why it is drawn and depicted as arrows that are bi-directional in this drawing. You will also notice that we have checkboxes there shown. And these checkboxes are made by Forcepoint to show where we contribute greatly to an organization's journey. Of course, we don't check every box because we don't provide every capability that is out there for a zero trust framework. And that's where partnering, with our strategic partners and in industry, it's going to come a long way. And that's something that we'll be eager to show you in the next phase. Next slide. This slide is going to summarize the optimal zero trust state because, as I mentioned in the previous slide, there are several maturity levels, optimal being exactly where organizations want to go. Evan, if you could just build it out one more step. So those check boxes that I showed you are represented here in these boxes, and you'll see from left to right how we have a user activity monitoring capability under the identity pillar. We also have, under device protections, we have cloud access service broker. We also have remote browser isolation. And you'll also see in the other pillars some of the other capabilities that we have. We are going to do our best within this time frame to show you how these capabilities contribute to a zero trust architecture, with our slideware and our demos. Next slide. Finally, I did talk about how we incorporate the DoD Zero Trust Reference Architecture and how we implement our tools and how we encourage our customers to implement our stack. But briefly, for those of you that haven't seen it, I'll quickly go over this so that you can understand it and then show you how we contribute. When you look at this diagram from left to right, you'll see that there are some major components that can be taken in piece at a time. If you look at the very bottom of the left, you'll see that it has an enterprise identity service component. And with that, we understand that that is an organization's capability to manage and provision digital identities across the enterprise. And that is integral to most organizations, as you need to have an accurate handling on who is in your organization, what they have access to, and proper governance for that. You'll notice above that is a client and identity assurance area of activities, and that is where we're going to do all the activities surrounding identity proofing and access management. Followed by that, you'll see that there's data-centric enterprise, where the majority of the resources are going to reside and the majority of your policy protections are going to live. And finally, on the right, you will see that there is a dynamic access control plane, and this is where you're going to have your security controls that are going to support your user behavior analytics, your SIEM, and your automation that's going to help determine who is trustworthy on your organization, who is not, and then be the kind of engine that's going to support dynamic access controls that we talked about that are key to the Nist tenets. If you briefly look from left to right, starting with the client and identity assurance tier, you'll see that there are two pathways for any type of transaction to occur within a zero trust framework. Starting on the left bottom in blue, you'll see that there's a path for person entities, and above that, there's a path for non-person entities. And you'll see that they differ slightly, but what you're noticing is that as they continue to move through the organization, they're going to be met with several types of decision points and all types of technology that's going to enable this. And if we now, Evan, briefly build it out one step, this is where Forcepoint can help organizations to implement this type of design. We have technology in many of those checkpoints that are going to facilitate a zero trust reference architecture and help to understand and implement access policies, beginning with having a unified approach, whether it is for data protection, application protection, and user protection. We also have a zero trust network access capability that we're going to show you in depth, and that will also provide other types of views that are not presently in this particular architecture, but that you will see is completely relevant. Next slide. At this time, I'm going to turn it back over to my colleague, Evan, so that he can start to show you what the use cases and demos are.
Thank you, Dr. Nick. Now we're going to be going over our product is Forcepoint 1. So with our Forcepoint 1 product here, we take a 3-to-1 approach towards our motto. So what we're looking at is we're protecting 3 channels of communication. So SWIG, Secure Web Gateway, CASB, Cloud Access Security Broker, and a ZTNA, a private apps or zero trust network access. So with those 3 applications, we're protecting them in 2 key principal areas. We're keeping the bad guys out and the good information in. So what we're looking at is threat protection and then CDR and all that other bad stuff. We want to stop that all from coming in. And at the same time, we want to look at them, what the user's accessing and how we can protect it from exfiltration or accidentally sending out traffic or data where it doesn't belong. And all of this is done through a single platform. Through that single platform, you have access to your policies, you have access to updates, management of your clients, and then the statistics and analytics that that's trending. So with with that said, the office has changed, the workforce has changed. HQ can be a local place where you can go to, or it's a remote branch site. It could be your workforce could be TDY, and they could be here within CONUS or OCONUS, anywhere in the world. Also, with that in mind, data is everywhere at the moment. And so we need to think about how we're protecting it. So with that said, with these changes, we have to change our mindset on how to protect this information and look at things from a global perspective. Forcepoint 1 is helping you answer these concerns by providing a positive control. Positive control over your data and your users accessing. So to expand on what Dr. Nick was referring to is, we got these pillars, right? Whether or not you've in the deep end with a bunch of applications, bunch of appliances, or haven't even set foot in that zero trust pool, Forcepoint 1 is going to help you reinforce your current posture or establish a foundation that you can build upon. So I went through that pretty quickly, mostly because I don't want to destroy you with slides. So let's get into the demos. Are there any questions? All right, cool. So we're going to move into our demos and use cases. So for our first use case here, we're looking at a remote worker in a public space, right? So this individual is moving around the United States. They could be any and everywhere. And that's just part of their job description, right? So let's go ahead and pop into our Forcepoint 1 portal. So I'm going to log in as me, as an administrator. And so how do we maintain positive control of this? So first part is we're going to go ahead and look at our login policies. We can control who's logging in, what groups they are, and what policies are they're bounced against. Right off the bat, we know that whether or not they're in the Russian Federation, Korea, China, using an anonymizer in Costa Rica, we don't want them into the network. So right off the bat, they're going to be stopped, and that's applying to everybody. Same instance, we want to make sure that those people that are moving around a lot, or if they're performing like some type of suspicious login or impossible travel, we're going to go ahead and do a 2FA, because you never know, maybe the transporter has been developed and that person is there with their phone. So that said, let's go ahead and jump in and log in as a user. I'm no longer Evan, I'm going to be James. So right off the bat, we go ahead and establish a connection with our IDP, and we're allowing our IDP, in this instance right here, we're connected with Okta. And all this action that I'm performing right now, this is all happening on my local computer, no agent, no extra stuff right here. So right off the bat, I'm logged in to my portal. And then as I'm accessing my CASB application, I'm SSO. So if we notice up here in the upper right-hand corner, I'm reverse proxying the connection. So agentless connection into your CASB application with SSO and reverse proxy. This means that we can maintain positive control of the data that they're accessing, the movement of the data, and all these other administrative actions that you need to perform. So moving back to our portal, like what else can we do with this, right? So with that said, we're gonna go ahead and look at this CASB application itself. So we're gonna go ahead and say that, oh, this person, anywhere in the world, we don't want them sharing it with our information. We can go ahead and add a RESTful API with our integration with it. We're gonna go ahead and look at what shares they're performing. If they share out something, we're gonna go ahead and stop it from happening, or as it's happening, as it's being processed through, we're going to go ahead and remove those people that have access to it. So this is your data. We're watching your data in motion and at rest. So let's go ahead and move back to our use cases. I'm going to look at use case 2. So now this is pretty cool right here. This is we're talking about a remote site. So this is where it goes into what I was referring to before. Like there's a global presence now, and you could be anywhere and everywhere, and you want consistency across all of your platforms and all of your industry, right? Or all of your locations. So what we're looking at here is that based on these individuals, whether or not they're allowed to go access a category or website, and based on its reputation, we can go ahead and let things happen or allow traffic to pass through. So let's look at this happening. So we're going to go back into my portal here, and I'm going to use my portal access to go and jump in my lab environment here. So we're going to go ahead and go on an agented device here. So this is an agented device. We know it's an agented device by the bottom right-hand corner. We got a little doodad in the right-hand corner showing our Forcepoint emblem. Show that we're going to be performing agent inspection here. So when we're talking about the SWIG functionality, it's pretty standard for a SWIG. You want them to be able to go to va.gov, right? You know, you want them to be able to do all their work and saying that they have to do some personal stuff, because certain individuals they're going to need to be able to access things that they need to do, like banking account information. They need to update their routing number, get it to HR. At the same time, we also want to protect the user from themselves and not do stuff that they shouldn't be going to, right? So let's say they're going to Riot Games, is blocked under policy. You know what? We want to go and gamble, again, being denied by policy. And so all this is happening on the fly on the client itself. So it's making all the decisions for you, so you're not bogged down. Same way, if they're going to a website that you find is unreputable, we can go ahead and on the fly spin up an RBI session, where this session is going to be isolated, or remote browser isolation. As we spin this up, we in the bottom right hand corner, we see a little emblem here showing that we've now secured the website and it's in an isolated instance. So to go along with this, we can go ahead and allow access to PDFs and everything else in between. And what we can also do with this piece right here is, as we're downloading this file right here, we're going to go ahead and sanitize it, passing it through our CDR application. These are all additional pieces to go along with protecting the edge or your end user. But this is all going above and beyond. So with our CDR, we're not just cleaning it and looking at the file itself. We're actually tearing it apart and building it back together. So this isn't a flat file where it's just an image. This is an actual test. It's a fully functional PDF. So it's totally searchable, usable, and then editable. So, sorry, let's now we're going to move on to our next use case here. So we're going to look at we're going to be looking at scenarios 3 through 8. when we really thought about 3 through 8, we're looking at protection of information in your data, right? So as traffic's moving from point A to point B, we want to make sure that everything is good. So what we're really concentrating on here is the fact that these scenarios here, they're looking at a DLP way to protect everything. So for these scenarios right here, although the location changes, our infrastructure and the means to protect the data does not. So it doesn't matter if it's in the cloud, on-prem, what type of information it is, everything has a fingerprint, and then we can actually look at the files themselves. So from here, I'm going to stop my share and turn this over to Mr. Porter.
Yeah, thanks, Evan. So as Evan was mentioning, what we're looking at here is going to be primarily a DLP focused solution of being able to control and understand where data lives inside of a controlled network. So a network where we're going to be able to install our data security tool sets to be able to monitor those functions, and then as well as monitoring the egress of data from machines inside that network or from the network itself over web or email channels, USB, printing, LAN transactions, etc. All of those are things that we're going to want this DLP system to enforce. And as he mentioned, from these use cases where we have contracted employees where they're communicating with data centers at different agency facilities, or they're working with systems that are hosted in either a VPC or a cloud, AWS, Azure environment. That doesn't necessarily change how Forcepoint's DLP is going to approach both the protection stage and our policy-based information on that. So our goal with the DLP system is to create policies and create rule sets that are designed to allow approved working use of data, but then also prevent either unintentional or accidental data leakage, or when from a more zero trust perspective, as well as kind of the main focus of a lot of organizations is prevent that data theft, the malicious users, the malicious actions. The way that we accomplish this is through policy actions here. These policies can be sorted into a numerous set of filters and categories depending on what is actually relevant to the organization, and they come in a couple of different formats. There are predefined policies and custom policies. Pre-built policies are things that and this is one of the standout parts of Forcepoint's DLP, is these are policies that come built into the solution to provide a quick time to value from a DLP standpoint. So I can go through and I can say, we have these different industry types that we're dealing with. So depending on what the actual relevance to your organization is, we're going to be able to just select these different category rule sets. And then we also have regional filters that might be relevant to your organization. So if you have to worry about, say, GDPR, you have to worry about different states or different regulations from going on there, the California Information Protection Act, et cetera. We're going to have policies and relevant information that's all going to apply to those systems at the click of a button. So once you have those filters set in place, you see I can go through and start looking through and say, okay, I want policies around USPII. I want to make sure that someone's not moving social security numbers or internal information. And this can be something that will apply to every organization, because even if you don't necessarily deal with customer PII, you still have employees, right? And that HR data is still going to be able to be something that we can protect. Now, in the specific use cases here, we have a contractor who's coming in and interfacing, working on a organization's systems. We're typically going to be dealing with either controlled data, so something they could be working with like CUI information or information that would be controlled under ITAR or EAR, export controls, and those sensitivity requirements, and we're going to have policies that are pre-built around that. And then at the push of a button, I'm going to be able to say, I want this policy to apply. Maybe I want multiple policies to apply to this. We're going to be able to hit use policies, and those are going to go into the environment. And what this is going to do is give us something that within seconds of deploying a DLP system, we're going to have policies that are already in place that at the very least are going to be able to start auditing and adding information to the system. Or if we wanted to take a more aggressive standpoint or more aggressive approach, With things, we're going to be able to have it automatically start blocking and alerting administrators on the fact that, hey, this data is being moved out from the environment. So again, in the system where a contract employee would be connecting through, maybe they're logging into a VDI environment, they're creating a virtual session, maybe even similar to how I'm connecting this through here, through a remote viewer, where they're actually logging onto servers and actions. We're going to have these policies that are going to be able to come in place to be able to monitor and control that information. So especially for like use cases 3 and 4, where they're specifically connecting either for development to production networks, these policies are going to be very useful, because if we go ahead and edit these and take a look at some of the actions and channels that we're looking at, we can monitor the different channels and the different rule sets that are going through. We can apply risk impacts to that. So coming through from what we were talking about previously with the behavioral analytics information that Dr. Lessen mentioned, where we can start establishing baselines for approved user behavior and understanding when people deviate and vary from those actions. All of those are going to be things that built into this DLP system that are designed to be able to function basically at the push of a button to go through here. Now, in the cases where we're talking about more information that would need to be entirely unique or entirely customized to the environment, specifically when we start talking about the use cases 5, 6, 7, 8, where the different agencies might be interfacing between each other and are dealing with fingerprinted information. Forcepoint's DLP has a built-in fingerprinting tool set that has a couple of different functions for capabilities, and that's going to be utilizing the capability for fingerprinted information inside a network, either from a structured standpoint where we're connecting to a database that might exist in here, or from an unstructured standpoint where they've got a set of control files and information that are stored in a deep storage unit or in a public place where we need to make sure that only specific information is allowed to move through. The DLP system is going to be able to step in and provide that unique understanding of that. Again, at fairly quick and fairly low overhead to install and set up. And the nice thing about these fingerprints is as data is updated and moved and it's a living information, these fingerprints will live with that. So no matter where they're going to be able to access that information from, as long as we have a system in place, as long as they're moving data over the network, we're then going to be able to have something in place that's going to provide that analytics information to the DLP engine. Once we have the analytics on the DLP engine, we're then going to be able to provide an action of, are we blocking this information? Are we auditing this information? Are we sending information to administrators, letting them know that, hey, we've got John over here who's just logged in and he's taking this fingerprint information, but instead of moving it across an approved channel, he's trying to upload it to OneDrive, or he's trying to upload it to a personal Google Drive. Those are things that we're going to be able to control and alert and have those policies be dynamic. Some of the other advantages that we have on here is the ability to have different policies apply based on source and destination. So certain users may actually be able to move this information to an approved OneDrive instance, and we can have that set up based on Active Directory credentials and communication. You see with users here, or I can even create custom users inside the environment. So for contractors who may not necessarily be part of the domain where the DLP system lives in, but they might have like a Windows NT or a username, a temporary username that they would connect in through a guest account. We can have that in here, which will then provide context and information to policies, as well as provide the capabilities for us to be able to create those context aware and those specifically targeted policies. Again, following those principles of zero trust, where we're not ever explicitly granting access. A user has to be explicitly granted permissions to take something. Otherwise, they're going to fall under this all category where we're going to restrict their access and restrict their use of the information. And expanding on some of that customized data, depending on what would actually exist, specifically with the use cases 5 through 8, where we've got these, they're accessing fingerprint information as part of an investigation process. Depending on what that information might be, there might be extremely large amounts of it. It might not necessarily be feasible to fingerprint an entire copy of it. We can utilize what we would call our machine learning rule sets to be able to understand the context and format of the data itself, and given a baseline understanding of a couple of sample files, we would then be able to extrapolate on new information that hasn't necessarily been seen by the system, but would still be considered sensitive and still be able to be blocked and controlled through the DLP system. And all of this is going to be done through this central management console. And then if there are violations, if there is information where users are actually taking this data out and moving this, in this case, like through an email, etc., we would be able to then go through and view full forensic information to be able to say, all right, I see this user has moved a file that contains something that has been considered sensitive information. In this case here, we've got a NSSN as an example, but this can apply to literally any file transaction or information. I can see that this was a network email that the user sent out. He was sending it to a Gmail account, so he might even be trying to send it to himself, maybe change his name up a little bit. And I want to preview some of the information that he's got in there. We actually can pull up the raw information, the files. And this is what's going to allow security administrators to, one, have an assurance that we are actually blocking and monitoring the information that we say we're blocking and monitoring, and that it's designed to control. This can help reduce and make sure that we're not hitting false positives, and make sure that the policies are tuned and appropriately scoped for what we're looking for, but also is going to give context information if you need to have your own investigation as to what's going on, who's stealing the data. Was this an accidental? Was this a pattern of behavior? We've got several incidents from this user over the last months and weeks, so this could be indicative that he is actually attempting to steal data through here. And all of this is going to be controlled based on the policies that we have in place and the information that we have in place to be able to say, based on these use cases, based on these control sets, we are sure that this user is stealing this data. And again, just to emphasize, where that data is stored, where that network exists, whether or not you're accessing from the cloud to an on-prem, from a cloud to a cloud, on-prem to on-prem, or from on-prem to a cloud system, we are agnostic in regards to that. Our system is designed to protect the data as it lives in networks, as it lives on users' machines, as it's being utilized, and then provide security administrators quick controls, effective controls, and effective logging information to make sure and verify that their controls are in place and being utilized effectively. So I think with that, though, that's going to be the use cases that I'm here to present on. Are there any questions or anything else to talk about? Let me know. Otherwise, Evan, I'm going to turn it back over to you.
Thank you very much, Mr. Porter. All right. So we're going to go on and move on to use case 9 here. So Mr. Porter has already gone over the DLP and what we can do there, but there's another piece, scenario 9 is where we flip it over and put the onus on the provider or the individual or the agency that's providing the information. In tandem with all of the DLP that we are capable of performing, we have another piece, the ZTNA right portion. So with the ZTNA, what we're going to do is go ahead and provide direct access, monitor all that information and whatnot that the end user is accessing, but we can provide it and maintain more positive control by funneling it through the Forcepoint 1 portal. So let's go ahead and set up a quick ZTNA connection. So the principle is going to be the same. So we're just going to go ahead and use Splunk because we have an internal application and we're going to provide access to it externally without presenting it to the internet. So no random user is going to be able to go to your the website. It's only authenticated individuals that are validated through your IDP, and then they go into the portal, and those individuals that are added to the policy that have access to the application can see it. That said, also at the same time, DLP is keeping a monitor on what information, what data they're accessing, right? So we're going to be going ahead and accessing an internal fully qualifying domain name through HTTP, but we're going to perform a reverse proxy function. So let's go ahead and move back to our policies here. So when we look at the Splunk policy, we're going to go and look at who has access to it. What access. So right now it's being accessed by anybody. So if we want to go ahead and just lock this down to specific people, people that need API access, we're going to allow admins and not contractors, but only IT. We can go ahead and lock it down to those individuals. We can lock it down to the point where those people that are accessing can only do it from an agented device. We can lock it down that they're only within a specific location, everything else in between. So as we save this, let's go ahead and look at my portal here. And as I refresh my portal, I now have Splunk just added it into my applications. After clicking on it, we now have access into my internal network, accessing my data. So what we're really looking at here is how quickly that you're able to spin up a ZTNA connection and then accessing that data that is over a secure means. So again, we have a SSL valid connection and is being reverse proxied. So then now we can look at all that information. So all this said, let's move on to use case 10. Use case 10 here, what we're looking at is we're looking at how do we troubleshoot? How do we look at it? There's remote users having issues. What do we look at? Where do we begin, right? So within our Forcepoint portal, when we're talking about logs, right? We don't mess around with the logs. Anything and everything within here, everything's logged, all the application, the locations that are being came from. And so the big one is we can look at health. We can tell that at this point right here, we were having an issue with Salesforce. This is from the Forcepoint UI going into the cloud, your cloud instantiation or your cloud application. And so we're actually monitoring your CASB application. So it's going to give you a heads up of what's doing, who's doing what, in the same instance, maybe there was a policy in place that is blocking that individual. So they're saying that, oh, I was denied because I was trying to download this. Like, okay, let's look at it. So they're like, oh, you were denied sending that email because you violated a policy. What did you violate? We're looking at it. Oh, you try to upload this. You violated the court records rule, and within there's social security numbers. You can't send that out. So it doesn't nitnoid with this portion right now. It's black and white. We know why they were denied, and within that they'll say with justification like, oh, I need to send something there because it needs to go to a judge. We can then modify policies. Or this needs to go in because these are HR people. Oh, we need to do this because it needs to go because these social security numbers are there because of social benefits. So we need to send that to the insurance people or anything else in between. We can work with the individual to troubleshoot and then determine what needs to be allowed through. So let's move on to the 11th use case, which would be compromised credentials. I touched upon this a little bit earlier, where we're talking about compromised credentials. We can go ahead and protect the individual through policy, where as the individual moves around, we'll take that first person that moves across the United States. It's not unusual for that person to travel from Chicago to New York, from New York to Las Vegas, and then to Los Angeles. But if that individual makes a movement from New York to California in under 15 minutes, now that's a suspicious login. So when they perform a suspicious login or that impossible travel, or even if they log in from a new device, we can go ahead and enable on the fly 2FA. So what we're doing here is rather than outright denying the individual, give them a chance to justify themselves. Maybe they discovered teleportation and we just don't know it, right? So if we want to go ahead and look at this, so James was initially in Canada. So let's go ahead and move him into somewhere else. I think this is France. So I spun up a virtual instance inside France. We're going to go ahead and log in as James Smith. Same interactions, IDP is going to catch him, forward him over, make him validate who he is. So these are the compromised credentials. And so going to go ahead and set up a 2FA. So right off the bat, because I performed an impossible travel, there's no way for me to get from Las Vegas all the way to France in under, we'll say this is 40 minutes, I'm going to go ahead and enable 2FA, and it's going to challenge me to validate my credentials. So if that person the person that's in the distance not going to be able to, unless they stole their phone and moved for 1,000 miles in 40 minutes, this is impossible. This is impossible to be done. So this is where we see that. And then this then ponies into our last use case here, right? Because what we want to do is penetration. So penetration testing is just another way to look at your network, because as people come in and attack you, or you pay them to attack you, you want to see what's happening, right? At the same time, you don't want to stop your network from performing or working, so then you can create policies to target those individuals. And then we can go ahead and look at these access, right there. There's James, he popped up. We can look at the event details. Oh, looks like I was in Singapore. That's where I was, in Malaysia. So it was challenged, validated, and then they're challenged. So same way we'll go for the penetration. So we can go ahead and look in the logs. We can see what they've attempted and what they accessed. And so from this point, I'm actually going to turn this over to Dr. Nick, because we have an open API for log collection that I was working with Dr. Nick, and going to turn this over for the behavior analytics.
Sure. Thank you, Evan. So you may recall earlier in the talk, we discussed the Cisa maturity model and how there were 5 pillars that contributed to that. At this time, we've demonstrated a platform called Forcepoint 1 that satisfies 4 out of 5 of those pillars. You've seen through one security stack, unified policies, unified view. What I'm going to show you now, I'm going to briefly share my screen, is an analytics platform that will then cover the visibility and analytics tier that we also discussed, that was part of that maturity model, and also that you've seen in our DoD Zero Trust Reference Architecture overlay. Okay, now this use case was about looking at the visibility that we can provide if there was a pen test going on, but this is not limited to that. This particular platform is going to give you 360-degree view of what's going on for all of your users. It is going to ingest data from any structured or unstructured source, and then it's going to provide a very essential capability for Zero Trust, which is providing that trust engine. The trust engine is going to be the means for you to determine who is trustworthy on your network. It's going to take these feeds about all types of events that are happening on the network. It's going to enrich them, and then it's going to look at individuals and assign what we call a risk score. And then we're also going to assign a risk level, which is another construct that takes the risk score and puts them into smaller ranges. And this particular risk level is one that is a little bit easier to share with systems. And what the purpose of that is, goes back to when we talked about the Zero Trust tenant that is looking for dynamic access controls. And so as we score these individuals based on the activities that we're picking up and correlating with indicators of risk, we are then sharing that score with other systems, whether it be Forcepoint 1 DLP, Forcepoint 1 CASB, or it can be an ICAM system. And we'll demonstrate some of that in a moment. They can then take that information and do some orchestration and dynamically adjust access. So as we go and look through this, you'll see that on the left, our system has an analytic dashboard that is going to look at all the individuals on the network, assign them those risk scores, and rank them. And you can see we've got a healthy list here, with 100 being the most risky and 5 being the highest risk score. You'll also see on the right that we have what's called scenarios. And these scenarios are collections of models that are related to different profiles of risk. And they're pretty intuitive based on the title. We've got one for malicious user, one for compromised user, one for negative behavior, illicit behavior, and data exfiltration. And you'll see some of the differences as we dive through the actual events that correspond to these models. Now, in the previous use case, we talked about compromised users and impossible travel, and I'll show you some examples of that, how it's captured in the system. And this is also related to the final use case where we would be looking at and assisting with a pen test, right? With penetration testing, we're going to want to know who's on the network doing what, and we don't want to catch those activities so that we can then work on those types of mitigations. And as you can see, as we drill into the model for compromised user, in the case that during this penetration test, a user was compromised and then used to then continue the attack on the network, we might be able to find evidence of that in this view. So starting at the top, you'll see that as we drill down, you'll have an hourly timeline that shows how that particular risk level has changed over time in the event that there is a change. You'll also see a heat map regarding all the activities that were captured that relate to those changes. You'll see that we've got the scenario on top and it's scored at a composite level, meaning that all the scores were factored in. Obviously, this is sample data, so it's going to be, not precise. In any event, you also have the supporting models that are all targeted around the types of behaviors that would constitute, well-known behaviors, that is, that would constitute a compromised user, potentially compromised user. They're pretty intuitive. You'll also see that we've got source country cardinality in here, which is completely related to the use case that Evan spoke about, where we could capture information about impossible travel, okay? Now, either you can click through the heat map or we can scroll down. You'll also see another timeline that breaks down each of those events. And if you were to look through the events that unfold, let's say during that penetration test, perhaps a user was sent some type of malware through email, you can drill into the event and you can see that this particular individual has looked at an email that says, go ahead and download and install this patch. And this particular individual believed that this was a legit email and followed those directions. And you can see that they downloaded the Windows patch, but it came from a URL that was not internal. And we're able to see all this through our analytics platform by pulling in events, whether we're pulling it in from our Forcepoint 1 or we're pulling it in from a seam. You'll also see how when we do analyze these events, how we're going to have rich information about where the actual event originated from and where it was going, as well as on the bottom, details about the event. And finally, in the middle, the most interesting aspects of the event that help us to make those events bubble up and they get scored. And there's things that like outlier detection that's applied here and peer group analysis that also support this as they get applied to the models. Continuing that story, you'll see how it was scanned and you can see how all of a sudden after that patch was applied, traffic is coming from all types of different areas. And we're starting to get alerts on our IDS systems. Traffic continues to come in. And as my colleague showed you, we now have VPN logins coming from China, Russia, and the United States. So now it's pretty obvious that this user is not, including Iran and India down here, it's pretty obvious that this user is not coming from one particular area. Okay, so you'll also see, now we talked earlier about data loss prevention and CASB as other mechanisms that can be used for protection. If we were to look at other activities during the day for that individual, we could look at the data exfiltration model. And this particular model is focused on resources that are going in and moving in and outside of the organization. And it has special emphasis on your highly sensitive data, if you will, that you should be protecting. Now with this same user, you can see how we're capturing information about what they're doing. You can see how the risk scores have changed from 3 to 5. And if you recall earlier, my colleague Chris Porter talked about an action plan in DLP. And that action plan allowed for a move from this legacy binary access of allow and disallow on a manual basis to a more automated way of dynamically accessing data and assigning these access permissions. And so with that data loss prevention, they can look at the risk level and they can determine that level of access. If it's at 3, for example, they could be just doing enhanced auditing. At 4, they could be doing forced encryption, and 5, they could be blocking. But as you can see that this user has already reached 5, and so any activity that this user does, it's going to be blocked. And this particular relationship between these analytics platform and DLP is very important, because as there's information going on around the network not related to DLP, this particular platform will take that information, score the user, and share that information with the DLP, so that that user may have been at a lower risk score, but perhaps in CASB or perhaps in the firewall, when they noticed the impossible travel, they bumped up the risk score within the analytics platform, and then that score was shared with DLP, so that DLP now thinks that that user is much more risky and will institute blocking in this case. And you can see that as what happened, okay? And we'll show you further evidence of this as this user continues to do things like executing commands that may be dangerous. You can also see that they are starting to try to upload to their Dropbox on the commercial side, and you can also see how DLP is blocking that. And it's mostly tied to the fact that there's sensitive information in there. And you see how we've got other information, how this is happening on a weekend, and you can see the severity. And all of these contexts are going to contribute to this being much more of a risky behavior. There's also examples where you can see if the individual tries to print things, DLP can quarantine them. And this is just showing you the art of the possible. It doesn't end here. That same risk score can be shared with your ICAM system. That ICAM system can then do things like disable the account. And if you don't want it to be that extreme, the ICAM system can then go ahead and send a notification to that user's manager, asking for them to do an access recertification. The ICAM system can also tie the risk score to any further access requests that come on. There's many other applications, so we're just giving you a few examples of those. You also have the ability within this platform to manually hunt for information. Sorry, I'm having a little bit of latency to my lab here. Let me just get through this. And this particular view is where you would actually do searches. You have the ability to work within your date ranges and keywords, or you can just use our query language and search for things. You also see how we've got all this data ingested in with multiple channels, all the different channels that we're pulling in, whether it's from data protection systems, whether it's from network systems, whether it's physical access. We have the ability to pull in badge readers. We can see what's going on as that user moves all throughout the organization, whether they're going into SCIFs, getting out of SCIFs. So we can actually create a better chain of evidence. We can figure out if the user's in the building. It makes it so much easier. We can look at systems administration activities, if they're doing shadow IT activities. All of these are coming from your enterprise systems, as I mentioned earlier, supporting that 360-degree view, that zero trust continuous access and authorization. I'll pause here to allow you all to have any questions. All right. Well, I will turn it over back to you, Evan. If there's anything else we'd like to show before we wrap up.
Actually, there is one more piece, since you mentioned shadow IT. there's two means of consumption for the shadow IT portion. We'll go back into that pen test portion. After you have your pen test, we can actually within the Forcepoint platform for all those agented devices, we can ingest either the logs, a report you generate, and then we can put it in here into your our Forcepoint platform. Through that Forcepoint platform, we can perform an investigation. These are the top applications that we're seeing, but overall, based off of the information that's provided to us, we have a repository of over 600,000 known applications, and then they're bouncing against like risk scores of how bad they are. From a single click, we'll say hostmeup.com. It's a bad risk score. We can go ahead and at that point take control of that application. All this goes into that awareness of your current state and your current situation. Now, I just wanted to touch on this one point before we moved on. And so that brings us to the end of our demonstration and presentation. Are there any questions? All right, great. Well, since there's no questions, we're going to go ahead and wrap up here. Thank you for your time. Here's a list of resources and links for our information. Yeah, thank you. Y'all have a great day.